Hey everybody, welcome back to CIS 17A. Today we are going to be covering lesson number 10. We are going to start to talk about arrays and how we can use arrays to solve a variety of different problems. So today we're going to be covering pages 377 with a small break in between 384 and 386 and then coming on back, wrapping it up on page 404. Also, not to get too far ahead of myself, the lab assignment for today is a much more straightforward program to write compared to the last one where we had to ask the people how many things do you want to add and are they a floating point, are they integer. So this is going to be a much simpler lab assignment for you guys this time around. All right, so with that in mind, let's go over to the textbook. So the pages that I just indicated cover the following sections of the book, and then we will wrap up all this stuff over here in the next two lessons. All right, so what is an array? Quite simply put, an array allows you to store and work with multiple values in the same data type. In other words, instead of declaring a variable like we normally would and say something like int days, where we create enough memory for one integer, we can add simply the square brace along with a integer value, a positive integer value, here in between, and now we just declared 6 instances of a integer variable called days. So that's it. So when you declare an array, you are actually creating a consecutive set of memory locations or a block of memory that your computer is going to be using. And it's important to note that they're consecutive memory locations because that has implications with respect to performance. It helps your program operate more efficiently when they're consecutive. So I remember way back at the start of the semester when we were still doing face-to-face classes, somebody had asked us about a question and I brought up something about RAM and how each time the program has to like load stuff into RAM and then take it out and load it in and take it out, that it can become, the memory locations can become very fragmented, and eventually that could be a very big hit on your performance for your computer program. And that's not a big deal for some applications like something like a word processor, but for something like a video game, that's very important. So just want to make sure that I point that out, that when you declare this, it declares it as a block of memory locations. All right. The number, or the way that we access the array, is through something called the subindex. And each individual part of the block of memory in the array is referred to as an element. So we use subscripting to delineate between the different elements, and we'll see an example of that in just a moment. Now it's important to note that the first element or first variable in the array is element 0, and that the last element in the array, in this case this is a 6 integer array, that the last thing is element number 5, so it's one less than the size of the array, but we'll talk more about that in just a little bit. So here we're just going to go through and give some examples of declaring arrays, but I want to go ahead and switch over to the compiler. Notice that I'm using Visual Studio now because the online compiler was just, it didn't do enough error checking for me and it was a pain. So I'm going to start using this, but you guys, like I said, you guys can use whatever compiler you want as long as you turn in your main.cpp file when you're done. Okay, so let's declare an array of integers. So I'm going to put the keyword int, I'm going to put num, that's going to be the name of my array. And then I could do this a lot of different ways. I could go ahead and just put a literal there, and this would now have declared an array of 4 integers by the name of num. So num0 through num3. Now, the other thing I can do is I can use a constant to describe the size of the array. So I could call this something like size, and then use the name of that constant, size. So this is also allowed. So the value that I put here to determine the size or the number of variables in my array has to be either a literal or a constant integer. Now it's also worth noting that it has to be a value of 0 or more. We can't have a negative array. So the array always has to have a positive number of things in it. So just to see, if I put something like -4, it says, no, you can't do that. It has to be a positive value. All right. So The other thing that's worth noting that I can't do, and that's a common desire with an array, is let's say that we don't know how many things we're going to need to put in the array before the program runs. Like, for example, let's say that we're going to ask the user to create some type of data, and we're going to ask them to do it as many times as they want. So they could enter data twice, they could enter data 20 times, they could enter data 200 times. We don't know how many things that we're going to need to store in the array. So the temptation is to do something like this, to declare, instead of a constant int, to just declare a regular variable like this, size, and then say we don't know how big the array is going to be, so the next thing we're going to do is we're going to ask the user to provide the size. And then now that we know how many things that the user is going to enter, we're going to make that the size of the array. Seems like that should be a good thing to do, but see the red squiggly lines of death, it's not going to let you do that. So make sure that you know that for a test, that the value we provide here that determines the number of things in the array has to be either a literal or it has to be a constant integer, and that it has to be a positive value greater than 0. All right, so there's all of our prereqs for initializing an array. So I'm going to go back up here and I'm going to go ahead and use const again. And there's nothing special about the number that I'm putting here. I'm just putting an arbitrary number for the size. Okay, so we're going to leave it here for now. We'll come back and do more with this later. Okay, so here's more examples of declaring arrays. Here's a little bit of a mention about the total size of the array. The size of the array is going to be dependent upon what types of data it's storing. So for example, storing an int takes 4 bytes of data. Storing a double takes 8 bytes of data. So that number times the number of things in the array is going to be the total amount of memory that it takes up. So that's just something to keep in mind, that the type of data that you're storing grows quite quickly depending on how many things that you're stored in there. So, all right, just a quick thing to note. Okay, so how do we access each individual element in the array? We do that with the subscript. The subscript is just simply the number that refers to that particular element in the array. So again, we note that we start with subscript 0 and we end with subscript that is 1 minus the size of the array. In this case, this would be an array of size 6. 1, 2, 3, 4, 5, 6. So we're always going to be at 1 minus the size when we refer to the last thing in the array. And we'll see why that's important to remember when we start to use things like loops to work our way through and initialize an array or read information from an array. Okay, and then here I think they're just telling you what I just said. So the C++ always starts at 0, and then the subscript is always 1 less than well, they're saying it in a different way, 1 less than the total number of elements in the array. Or the easy way to think of this is just the size of the array minus 1. All right, so when we want to use an individual element of an array, we use it just like we would use any other variable, except for we include the subscript here between the square braces. So important to note, we're not initializing an array or declaring an array. We're actually using the 0th or first element of the array, and we're assigning the value of 20 to it, like we see here in the picture. Now, notice that assuming that this is an array of size 6, that if this is all we had done to it, notice the contents of everything else. So if we declare an array, like we did here, and then I say num0 is equal to 12, and then just for fun, let's see out num0, and then let's also go ahead and print out a space and print out the next thing in the array, num1. Okay, so we know that it should print out for the first thing 12, and then what it prints out here is, like in the book, it's anybody's guess. It's a mystery. Let's see what we get. We get a runtime error. So it's telling me that that the number being used is being used without being initialized. And that's exactly what we just said from the book, is that num1 has not been initialized to anything. It's just a garbage value. So in this case, it's not even going to let me do it. Let's try to hit continue. Let's see what it does. Oh, there we go. Negative, let's see, 1, 2, 3, 4, 5, 6. Negative 858,999,000. Anyways, it's a random number, right? All right, moving along. So we can see that's the value. All right, some random number. Okay, down here, they're just showing you that, you know, if you jump ahead and you go from 0 to 3, you know, that's going to now have a valid value, but it doesn't mean that these are suddenly valid. These are all still garbage values. Okay. Here they're just trying to say, make sure that you understand the difference between when you declare an array, the size of it that you put in there, and the subscript being of the last thing being 1 minus the size of the array. So they're just saying don't confuse when you use a number between the braces when you declare an array versus when you're actually using the different various elements of the array. Okay, so here is an example of initializing an array, one thing at a time, and then printing everything out, one thing at a time. Rather tedious. We'll see later how we can instead do this using loops, and it's much more efficient. Okay. So this is what I just said. So here we're going to use a loop instead of using a sequence of CN statements to initialize the contents of an array. So here we're just using a simple for loop, and we have a constant that we're using that represents the size of our array, and we're going to have a count that represents the subscript of the element. So starting off at element number 0, and then we're going to loop while count is less than the size of the array. And that's important that we're using strictly less than, not less than equal, because if we went less than equal, we would try to access numbers 5, and there is no numbers 5, right? It goes from 0 to 4. All right, and then here we're going to use the iterator count inside here as our index into the array. So here we're starting at number 0, we're setting it to 99, and we can see what this is going to do is it's going to loop through and it's going to initialize the entire array to the value of 99. Now there's nothing special about that. This is just simply an example of showing you how to use a for loop to initialize an array. And instead what we could do is we could actually do this. We could actually ask the user to provide a value in each iteration of the loop. So here we have employees, total of 6. This is going to be hours that they worked, and num employees in this case is acting like an employee ID number that for each employee will tell us how many hours that person worked. So we can see down here, same for loop that we had before, and it's worth noting that it's kind of odd that they're doing this, that they're declaring count outside of the for loop. Normally when you use a for loop, you just declare the whatever controls how many times it loops, you declare that right here instead. So it's kind of weird that they did that. So we're going to start off with count equal to 0, count less than employees. Again, note that it is not less than equal, it's strictly less than. And then count is going to be acting like our employee ID number here when we actually enter in the value. And also notice the way that it's being used here. So we're going to enter the number of hours worked by employee. We know count is equal to 0 the first time, and then this is just simply a formatting thing. They didn't want to refer to that person as employee 0, they wanted to refer to him as employee 1, so they added a 1 to the count here. And then we just simply read in the value for how many hours they worked. So 20 hours, 12 hours, 40 hours. Ooh, employee number 3 is really going for it, man. And then down here, we're going to use another for loop to print out the contents of the for loop, which we see in this very last line here. Count is equal to 0, count less than employees, and then we just do a cout statement. Okay, so let's go ahead and jump back over to here. Let's kind of play around with this a little bit using for loops. So we're going to say for, and let's go ahead and say that this is going to be us filling up the array. I'm going to say int I equal to 0, and it's very common when you're doing stuff with for loops and arrays that you do this, that you initialize starting at 0. And then it's very, very common that you do I less than, and then size in this case, I plus plus. And you may ask me or be thinking to yourself right now, oh, Mr. Fast, why are you using I? What's that mean? And many moons ago, when I was a student back at RCC taking CIS 17A, I remember asking my professor, does that stand for index? And he said, no, it's just I. So there you go. It's I. All right, so we're going to fill up the array. So we're going to just simply do something like a cout, where we ask the person to enter a value. Okay, and we use I here. Okay, and a little semicolon to make it look nice and pretty. That's it. Okay, next we need to read in the value from the user. And again, we're going to use I as our index. And that's it. That would go ahead and fill up the array. All right. Now, I'm going to go ahead and copy and paste this and make a cout statement so we can just see what was actually entered into the array in just a second. But I want to note here the advantage of using constant ints to describe the size of the array. Imagine that if I wanted to, instead of reading in 4 things, I decided, you know what, actually I'm going to need to do 8 things. Well, if I had done this when I declared it and said this has 4 things, now everywhere else where I'm using the size of the array, like here, and then in the other for loop where I print things out, I would have to tediously go through and change each one of those from 4 to 8. So notice the advantage of just using a constant. I only have to change that value in one place. So now it's going to work for 8 things. Now it's going to work for 6 things. It's going to be very easily to modify if I decide later that I need to change how big the array is. Okay, so next we're going to go ahead and just do a readout of the data that we put in, and I don't want to read 6 things in there because it'll take too long, so let's do 3. And then we'll do just simply this. Value for element I is num I. All right, so that's going to print out the contents. Okay, we may run into some formatting stuff here, but I don't know. Let's find out. Okay, so we're going to read in 3 things. So this is element 0. We'll put 2. Let's put 42 for the answer to everything. And then let's put 78. And yeah, that's what I thought. I got some formatting stuff. Let's go ahead and just add a new line in here. Indel, there we go. Let's try that again. Let's do, this time let's do 5, and then let's do 21, and then let's do 6. And there we go. Value for element 0. It still looks bad formatting, but that's okay. You guys forgive me. 0 is 5, 1 is 21, and 2 is 6. All right, so there you go. That's how you can fill up an array, and that's how you can read off the data out of an array using a for loop. Okay. You can use any integer expression in the array subscript. So what they're saying here is that you don't have to start at 0. You can start at something like 1, but then take in mind that if you're going to start at 1 and you want to go through everything in the array, you're going to have to do it not less than, but less than or equal to. But then in order to not avoid going outside the boundaries of the array, you're going to have to account for that here when you're actually accessing using the subscript. So you got to decrease this by 1 each time you use it if you do that. Okay. Let's see. Here they're saying what not to do. Here they're saying, let's say that you try to read something directly into the array. This doesn't make any sense because this is just the name of the array. This is not the name of any particular element of the array. And we'll see later that this is the value for the name of the array is actually just the address of the first thing, the memory address of the first thing in the array. So you can't do something like this. All right, so don't do that. Also can't do this, can't read out that value to see what the memory address of that array element is. Okay, that's the end of the first set of stuff. You'll notice that anytime we do file stuff, we skip, I'm going to skip over that. That's more of something that you would see in CIS 17C working with files. So we're going to jump down here, 2, 3, where are we? We're going, we're going, we're going. All right, this is where we're going to pick up bounds checking. So notice that before I was making a big deal about that the not the address, that the the index number for the last thing in the array is the size of the array minus 1. So it's a common mistake to accidentally go outside the boundaries of an array. And it's important to note that that will actually cause your program to potentially crash. So here they even warn you not to copy and paste this code and then try to run it because it will likely cause the program to crash. Notice they use the word likely. Sometimes you get lucky and it doesn't. Last semester I copied and pasted this in. It worked like every single time. It just printed out garbage for the last thing, like we saw earlier when I did the example of going into an uninitialized memory array. But often what will happen is it causes the program to crash because the operating system can detect that the program is trying to go outside of the boundaries of the memory that's been allocated to it. And that's one form of hacking. So when the operating system senses that a program is attempting to go outside of memory that it's been given, the operating system steps in and just terminates the program, crashes it. All right, so what's going on here that's wrong? I should leave this up to you guys to figure out what's wrong, but I'll go ahead and go through real quick. Let's see, count is equal to 0, that's fine. Count is less than 5, there's the problem. So we're trying to loop through 0 through 4, but this is of size 3. So the last thing in this array is index number 2. So we can't go to 4. Okay, that'll cause the program to crash. Okay. Okay, what else? I can't remember what the point of this is, so it must not be important, right? Oh, just more stuff about checking outside the boundaries of the array. And then this is what I just mentioned, off by 1 errors. So this is an off by 1 error. Size is equal to 100. They're doing it for count from 1 to, well, they're doing it wrong in 2 ways here, right? So that if they're going to do it this way, see down here, yeah, okay, so this is off by 1 at both the head of the array and at the end of the array. So this count is equal to 1, and we initialize the first thing to 0, but this is going to skip over numbers 0, right? Because it's starting at count 1. Plus, it's going to try to attempt to access outside the boundaries because it's going to loop all the way to size, which is 100, but we know that the index of the last thing in the array is 99. So this is going to potentially cause the program to crash. This is going to potentially cause it to miss one of the things in the array. And those are both examples of off by 1 errors. All right. You can initialize arrays just like you can initialize regular variables. And we do that by using the curly braces to give it a value. So in this case, we got days, months. This is going to be the number of days in that particular month. All right. Let's see. Okay, note that you don't have to put everything on one line. So here they just hit enter here and then tabbed over and started entering more stuff. That's not uncommon to see. And then here we're just using a for loop to print out what was input. Okay, here's just them reminding you that you don't have to put everything on one line, that you can hit enter. You might say, well, why did you want to do this? It's just, but it depends on what you're trying to represent with the array. So for example, if you're trying to represent something like a screen, the pixel values of a screen, you'd have, for each array element, you'd have to have the RGB value. So you have 3 numbers, so you might break it up into like groups of 3, right? So there's just lots of different ways you can format this when you do it. Let's see, an array of strings with the planets. There's 9 planets, but we know that poor old Pluto just got demoted a couple years ago, right? Now it's a dwarf planet. I guess it was more than a couple years ago now. Okay, kind of a cute program here where they're showing you what the ASCII value of different characters are using static casting. Okay, so again, the main thing here is that they're using, again, curly braces to initialize the array. So no need for a for loop to initialize it, right? Everything is provided right there at the beginning. Okay, now what happens with partial initialization? We say that the array is size 7, but we only provide 4 things in the list here using the curly braces. What happens simply is anything that comes after this in the array is initialized to 0. So we're going to have 7 things. So 0 is going to be 1, 1 is going to be 2, 0, 1, 2, 2 subindex 2 is going to be 4. You guys get the idea. And then the last 3 things in the array are going to be 0, 0, 0, like this. Right. Now, one thing to point out, you can't leave empty spots. So I can't initialize part of the array, leave an empty spot here and here, and then like reserve those for later and hope that those are going to be initialized to 0. The compiler won't let you do this if you try to do it. You have to provide numbers. You can only provide default values of 0 to anything to the right of stuff that has already been initialized. Here's something kind of fun, implicit array strings. We don't have to put anything here if we do this. So this is going to go ahead and automatically figure out that there's 1, 2, 3, 4, 5 things in the array. So we don't have to put 5 here. If we do this, it'll automatically make this an array of size 5. Okay. Now this is more of what you already saw. So we already saw, like in the examples that I was giving, how we use the individual elements of the array just like we would anything else for like a CN statement. But if we wanted to, we could also do something like this, where we say something like see out the number times 2. So let's go ahead and see how that would work. So let's go ahead and put in 2, 3, 4, and now it's going to print out those numbers times 2. So prints out 4, 6, and 8. So there's nothing really special going on here, other than that we have to make sure that we include the index when we're trying to process the value of that particular element of the array. We can use pre-increments, post-increments. The only thing to be careful of is, again, don't confuse the value of the index to the value of, or I'm sorry, don't confuse performing a mathematical operation on the index and moving around through the different elements of the array to changing the actual value of a particular element of the array. All right. Okay. Starting to run a little bit long on time here, so I'm going to go ahead and leave you guys to go through this code and understand it. This is going to allow you to just enter how many hours an employee worked, and then it's going to calculate based on a fixed rate of pay how much each of those employees made, and they're doing that here inside of this loop. So they're just going to take hours that particular employee worked, multiply it by the pay rate. So back when this book was written, it was probably minimum wage is probably like $5.25. So then number of hours times the pay rate, and that gives you the gross pay of that particular employee. And again, they're using +1 because they don't want to have employee 0 for some reason, because why would we want to have employee 0, right? I like employee 0. I would just leave employee 0. Showing how you can use them in a comparison. You can compare two things in an array. Is the thing in array subindex 20 less than the thing that's at the very start of the array? But we can't do this. Thou shalt not assign. We can't do this. We cannot just simply go in and say old arrays, so old array values are 10, blah, 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 blah. We just want to copy these values over into this new values array by saying new values is equal to old values. Because again, this is not a value. This is the array's beginning memory address that is being stored in here. So for example, if this is just some arbitrary number, the name of the array is just the address of the first thing in the array, right? To access that, you would have to then actually say the name of the array sub 0, right? Or index 0 using the square braces, okay? So don't get confused with the names of the array. You have to use the square braces to dereference the array value. Here they're just saying the same thing again, right? New values, the value of this variable is this memory address. Okay. I just showed you guys an example of how to print the contents of an array. Summing the contents of an array. You just have some variable that we put right before the for loop, initialize it to 0, loop through one at a time, and say total is equal to total plus the value of the current thing here. Starting at 0, working your way through. So this will give you the sum of the array. And here's your reward for sticking around at the end of the video. So getting the average of the values of an array. Here is the solution to the lab. There you go. You're welcome. Add everything up in the array. We have a total that starts at 0, and then when it's done adding everything up, divide it by the size of the array. So the total is now going to be the sum of the array divided by the number of things, which is equal to the average. So this is the solution for the lab. Here's another solution to today's lab, finding the highest and lowest values. Start off by assuming that the first thing in the array is the highest. Work your way through. Why are they starting at 1? Oh, because they already used 0. So right. So we're assuming the first thing in the array is the highest, and then so we don't need to check to see if the first thing is bigger. We're gonna then start at the next thing in the array, and then we're gonna loop through, and we're gonna say if the thing here is bigger than what I currently think is the highest, then I need to reset this to be the highest value. So highest is now equal to the thing that I'm currently dereferencing. So that's why we're starting at 1 instead of 0. Now, fun to note that you could start at 0 and it would still work, but it's just taking note here that you don't need to do that because we're assuming that the first thing in the array is the smallest. So there's the solution to the lab. That's how you find the highest thing. That's how you find the value of the lowest thing. All right, so there you go. Those three things together form up the solution to today's lab assignment. Okay, more on partially filled arrays. Let's see. So here what they're saying is, I'll summarize this for you, is that if you don't know ahead of time how many things you are going to store in the array, and you're going to ask a user to provide information and start filling the array with that information until they don't want to enter that information anymore, what you can do is you can just make a really, really big array and hope that they don't have to store more information than that. This is actually a very common thing to be seen with video games where they don't like to use what's called dynamic memory allocation. They use static memory allocation. So the difference is that static memory allocation means that the compiler knows when the program is compiled how much memory it needs, versus determining how much memory a program needs while the program is actually running in real time. So the difference is that this is performance-wise much, much, much faster than dynamic memory allocation, where you allocate memory at runtime. Okay, so here they're just saying like we'll make a really big array, and then we'll ask the person to start entering data, and then while the number is not equal to -1 because -1 means that they want to quit, and while the current count of numbers through the loop is less than the size so that we don't override and go outside the bounds of the array, do the following: increase the number of times we've gone through the loop, assign a value to that array element, and then ask the person to enter a number or quit. And from here, enter a number. If it's -1, when we come back up here, that means that they wanted to quit. Otherwise, we come back into here and then store that number into the array. And notice that has to be count -1 because it's on not the first iteration, but it's on the second iteration of the loop that it stores this value into here. Now, maybe a little bit confusing, but if it is, don't worry, because I'm not going to get hardcore into anything like this. All right, let's see. This is more file processing stuff. So yeah, so you guys don't need to know any of this file processing stuff. I'm not doing file processing in the class. Okay, I think we're almost done. Comparing arrays. Here we're going to go through and we got two arrays, first, second. They, in this case, happen to be initialized with the exact same thing. We have a flag variable, and we simply go through here and we check each thing in the array to see if they're the same. If they're not the same, we set the flag to false, and then the next time it comes up here to loop, always equal is now false. False and anything is always false, and so it stops looping. Down here, it uses the value of this to determine what to print. If it never set off this flag, in other words, if all the things were the same, then this is going to be true. It's going to say the arrays are equal. Otherwise, it's going to say that they are not. So comparing if two arrays are equal to each other. Okay, and then this is just talking about something I mentioned right at the very beginning, and this is the last thing I'll talk about, is that you can use the index of the array, or think of the index of the array as like an ID number, like your social security number. And then you can have multiple arrays, and you can use that index to figure out different things about that particular ID number. So how many hours did that particular ID number work? What is the pay rate for that particular ID number? So remember, earlier examples, the pay rate was always the same. So by using two arrays in this one, we can store how many hours did that person work and how much do we pay that particular person. Okay. And I think we're done. Yep, that's it. All right, so there you go, you guys. That's lesson number 10. So as usual, if you guys have any questions, don't hesitate to send me a message through the inbox. And good luck.